Welcome to my projectbazaar.com.
Image classification is a very active research topic which has stimulated researchers in many important areas of computer vision, including feature extraction and feature fusion, the generation of visual vocabulary of the quantization of visual patches to produce visual words, pooling methods, and classifiers. In image classification, it is an important but difficult task to deal with the background information. The background is often treated as noise. Nevertheless, in some cases, the background provides a context which may increase the performance of image classification. Experimentally analyzed the influence of the background on image classification. They demonstrated that although the background may have correlations with the foreground objects, using both the background and foreground features for learning, the recognition yields less accurate results than using the foreground features alone. Overall, the background information was not relevant to image classification. The results shows that combining co-occurrence and spatial contexts improve the classification performance. From the previous work, we conclude that image classification is faced with the partial matching problem. Some features obtained from the images in the same class differ significantly from one image to another because of background clutter and occlusion of the foreground objects by the objects. The influence of background on image classification varies. Only semantically important contexts such as obtained object co-occurrence or particular object spatial relations are helpful for image classification. Backgrounds which contain only clutter provides no information to support image classification. It is interesting to filter our background clutter and simultaneously use the background context to increase the performance of image classification. In order to deal effectively with the background information, we propose a salient-driven nonlinear diffusion filtering to generate a multiscale space in which the information at a scale is complementary to the information at other scales. The fusion of information from the different scales may improve the image classification performance. The proposed system which is proposed saliency-driven image multiscale nonlinear diffusion filtering. The resulting scale phase in general preserves or even enhances semantically important structures such as edges, lines, or flow-like structures in the foreground and inhibits the smooth clutter in the background. The image is classified using the multiscale information fusion based on the original image. The image at the final scale at which the diffusion process coverages and the image at a middle scale our diffusion process coverages algorithm emphasizes the foreground features which are important for the image classification. The background image regions, whether considered as context of the foreground or noise to the foreground, can be globally handled by fusing information from different scales. Here, this is the system flow. This is the first part, which is the input image. Here we are applying the image which is to be classified. That is, we have lot of database images in our database. So we have to select an image as an input. So then next part, object detection. There are a lot of steps are included, such as user extraction is next step. Before that, we have to select the object or from the image, and it separates the foreground and front ground. So object is detected separately. Then the detected object it is passed to the future extraction. So then the image is detected as object. Then the object is extracted as future values. Then that is enrolled or verified part. And in this part, the future extraction values are taken and which is compared with the database. So with the database and the current image values, the matching part is performs. The matching part which is nothing but that is a classifier performance. Here the classifier we have used is SVM, that is support vector machine classifier. That classifier classifies the image and which provides the results, and that means that classifies the image. That means it provides the classified images like a bicycle or bike or anything else which is selected an image. Let's see the running procedure. Here click the main file which is in the name of saliency. Run the file. You will get the new design. That is the guide window. So this is the first part, which is to select the image. Here, while you going nearby the button, the image tip will show you as what we are going to do by pressing that button. So the button shows click to select an input image. So while clicking this button, we will get the database. So from the database, we have to select any image as input. So here we have selected an image as flower. So this is the next part, pre-process. While clicking this new pre-process, we will get a new window, and while clicking this button, the process will as noise-free output. Here, this is the original image. Here for noise removal, we have separated the channels as red, green and blue. So we have noise removed from each channels and finally we have combined all images and it produced filtered RGB image. So to go to mainframe, click here and we will get here. Here, while clicking this button, here the filtered image will appear. Next process is image diffusion. So by pressing this button, the diffusion process will continue. Here you can see the process is going on. So this is the nonlinear diffusion, and this is the gradient magnitude. Here the diffused image will appear in mainframe. After the saliency map, while clicking that here the saliency map appeared corresponding to the image. After that, multiscale fusion. So here the fusion is operating in multi-level, and after the segmentation the result is shown in 9 levels. Finally, the fused image can show by clicking the image fusion button. Here this is the image of input which is after fusion. So our next part is feature calculation. Here for feature calculation we have used a shift feature calculation, that is scale invariant feature transform. So here these are the key points. From these key points we have generated feature values. Then next is identification. So after clicking the identification button, here we got the output as identified image is a flower. Then diffusivity. Here we can see the diffusivity in multi-levels. These are depend on the lambda and the m values. So here we have shown in 4 levels, diffusivity and flex. So after that, performance. These are the performance comparison between existing and proposed system. Here you can see the recognition rate. Recognition rate is higher than existing system, that is single scale method. Our multi-scale method is better than single scale method. So next, error rate. Error rate is less than single scale method. Thank you.